Right, welcome to IT Security Labs. My name is Howard Mukanda, and today we're going to complete a room code publisher from TryHackMe. Looks like they updated the interface. It looks really great, so I chose the first room I could see. My main goal here is to just learn some ethical hacking and just see if we can build some muscle memory on how to look at vulnerabilities in applications. So right now, I'm starting the application, make sure that it works in TryHackMe, and this will probably take a minute or so to get started, but let's read this. The Publisher CTF machine is a simulated environment hosting some services. Through a series of enumeration techniques, including directory fuzzing, so go buster, and version identification, a vulnerability is discovered, allowing remote code execution. So we already know we're looking for an RCE, which is a public exploit. Attempts to escalate using custom binary are hindered by restricted access to critical system files. Okay, so we already know what this is going to be all about. So while this is starting, let's go to our Kali and start a terminal. First, I'm connected to TryHackMe using the TryHackMe VPN. All right, so our machine started, it's a 10.10.4.140. So I'll come here and say nmap. So with the CTFs like this, it's a bank job. Just get in and out. So there's VV. We don't worry about OPSEC or anything like that. So we're running nmap. Service version, give me a service version because I was told the versions really matter. SC and VV to make sure that it's verbose. We already know that there's port 80. So let's go and visit port 80. It says SPIP 4.08 here. I already see. SPIP 4.08. Is that what it is? At the bottom here, it might say powered by. There's HTML version 1, I don't think so, but it says SPIP up there. SPIP 4.08. Okay. So before we do any directory fuzzing here, let's look that up to see. All right, here's remote code execution unauthenticated. The machine did tell us that there's going to be remote code execution. So I don't want to waste any time. So the creators did say you might need to bust some directories, so we are going to do that. So I'm using go buster in directory mode, and we are using 50 threads. That might be overkill, but let's see if I get lucky. All right, we'll let it run. Oh, actually, here's also see that there's another one on GitHub, like this one here, from like 8 months ago. This one also explains how they are doing things, including how they're running the curl command. So I like this one better. So because of that, I'll borrow this. I'll actually just borrow the one from GitHub because at least it has some usage. The one from ExploitDB, I mean, it's there, but it won't help me as much. So let's do this. Let's say nano exp.py for exploit.py. Control X, Y, enter. So now, if I do a Python, exp.py -h, this would take me to, oh, you want the URL and command. Okay, I'm saying in Python 3, go to this URI because that's the URI that we have. If you go to our site, there's actually an /SPIP. And go buster will also find this here. If I do this, something like this, and I'm going to run a curl to reach out back to my attacker machine and run rev.sh and pipe it to bash, that should work. And instead of rev.sh, I just put a reverse shell. Just put this here. This saying, hey, bash, can you please run a reverse shell back to my attacker machine on port 444. So here we have a 444 listening. We have our payload in this folder. So we need to host it. All right. So payload is being hosted. We have our listener here and we have a command. Let's run it and see. All right. It looks like it worked. We didn't get anything back. Now that's a problem. But it says it executed it. So what I can do is actually bash reverse shell one-liner. There we go. You can use ref shells as well, but so we're just going to change the IP address for this to be our attacker machine, which is 10.13.53.67. Okay, let's use quad 4s here because I'm already listening there. I can use the terminal, or I want to show you CyberChef 2-base-64. The terminal is faster, but this is also a cool way just to show you something different, because we'll always use the terminal to base-64 our stuff. So now that we did that, let's try to rerun our command. But this time, instead of piping to base, bash will type to base 64-D to decode. And here we're giving them, let's echo this and pipe it to base 64-D. Let's see. It looks like it worked. But nothing to my listener. Why is this not executing? I need to tell this to be ran by bash. So pipe this to bash. We need to tell it like, hey, you're using bash to run. There we go. This time it's hanging. I'm looking forward to a reverse shell. Boom. Okay. All right. So the correct syntax was to run our exploit encoded, was somehow it wasn't working, base 64, and then pipe it to bash. And now we get a reverse shell. They do say that in privilege escalation is there's some protections in place. So I'm looking for that. ls config. Okay, cd search home. Let's see who is here. Think, cd think, ls. Okay, cat user.text. I guess we might as well grab our flag right now. Copy that. Give it to them. All right, now ls-la under think. Oh, .ssh is here. cd.ssh. ls.la. Do you have them? I can read. Okay. Cat id underscore rsa. We're just gonna steal this here. All right. Now that we have the correct key, let's get in there. Control X, Y, chmod. Like that. Let's do an SSH. There we go. Once you copy the entire key, of course, it will work. Okay. Right. Sudo-l, just in case we can run something as sudo. We can't, so we just hit enter to get out of here. All right, so we cannot run sudo. We need suid. That's the next step, is let's check for suids. Okay, Linux privilege escalation from hacking articles. Here's a find for suid. First method. Paste it there. So the order of business for me is I first start with making sure that I don't have sudo. Then suid. If I don't see suid, I look at the kernel. Then I might whip out, something like exploit suggest or something like that. This is new, and also ppd is new. I don't know about that, but run container is definitely something that I'm interested in. So we can run this binary here. It has root on it. Let's see what it does. List of containers. Name that, status that. Enter ID of the container or leave blank to create a new one. Oh yeah, I would like to create a new one. Okay. Enter the container ID or leave blank to create a new one. Oh, run container.sh variable. Command not found. So container.sh is not found in opt. Okay, so that's good. So let's just quit ls-la/opt. Can we write in there? Nope. Nope. Okay. So that's going to be a problem. We're missing a. I was hoping that I can just go and run this right away, but I can't. So I got stuck here because I didn't know what I was looking at. Like, how can I modify that run container.sh? Then I go to such opt, no, etc app armor. So app armor will be used to restrict, just like what regular file permissions are, but this one actually tells us how things can be done, and it's using ash instead of bash. That's something new for me as well. Now let's see what they're actually restricting. So it looks like we have a deny on opt, which is interesting. So we also have a bunch of deny like on such temp, which is interesting. It does look like the script is looking for a Docker container. So let's go back to the script. In this script here. So list containers, Docker PS. Okay, we're not telling Docker where the containers are. If Docker is going to run this script, it is trying to validate a container using this script, I think we should be able to. Okay, so it looks like we are running that binary with SUID to that reaches out to this script here. But that binary, does it check the path of where this script is? Because if it doesn't, then we can give it a script to where we wrote it. Is it just referencing run container, or is it actually pointing to it? Okay, so it's going to /opt run container.sh. So we know that we have app armor in place. So I remember we have a hack tricks room where we can just go and see app armor bypass right here. In this bug, we can see example even if we have Perl. Okay, so let's try the Perl option here to bypass app armor. We can change that very quickly to, okay, so instead of such temp, let's put such dev /shm. This is another path that we can always write to in the system. Then we change this one as well to /dev /shm. Okay, I'm not changing anything other than those two. Copy that. Come back here. Because we could not write to temp. Oh, come on. Okay, /dev /sm. All right, so the bypass is in place for app armor. Okay, ID. Okay, I'm still the same user, but I hope this actually allows me now to see if I can modify the script. Such run _ container.sh. Oh, look at that. We have full read write execute in this container. So here's what we can do. So now we can say nano /opt.sh, because earlier we couldn't. And now, you know what? Let's put it at the top here because I'm not feeling it. So first, copy the bin bash /user bash. And then after that, we would like to make it into an executable /tmp. Now that we can write there. This is a clean way of doing this. That way I don't just drop into a shell. I just do this. So I can Control X, Y, enter. Now let's run the script to make sure that it actually works. So come back here. We say we want to run. Okay, let's do one. Start container. ls/tmp. Okay, I get my bash ls-la /tmp. Let's see, make sure that it is in SUID bit. Boom. So we do have a binary now with an SFD bit that we can run. So we can just go to cd search tmp ls and do the /bash id. Who am I? Wait. That bash file does have work bash -p id. Okay. Who am I? I'm now root. Okay. cd / root ls cat root text. All right, so that was a little bit fun. All right, so we grab our flag and we give it to them. We hit submit and we finish the room. So thank you very much for joining me. I hope you learned something new and I hope to see you next time. Thanks.